Thanks for listening. What I basically wanted to talk about is how my team, Expedia Group Engineering, are using open source and where we've seen gaps in the open source actually contributed back to that. So this is more about sort of like open source culture, how we encourage it in our company, and other companies I believe should as well. And if you've got the ability to actually go out and create that gap, then you should contribute back to the community. So a quick word about Expedia Group. I'm sure most of you have heard of Expedia Group. They're actually made up of 23 different companies, the world's travel platform. I happen to work for hotels.com, but there's been a very big push to bring the brands more into alignment recently. And from a data point of view, as a data guy, there's tons of exciting data there. And the kind of like the way analysts need to stitch all this data together kind of keeps me in a job. So that's very useful. A little bit about me. I like to think of myself as Thor, as you can see. I was at IBM for many, many years. I know I don't look like I've been there for that long, but I was there for a long, long time. I worked at Sky. There's a few people from Sky here tonight that have come to support me. Yeah, go ex-Sky. But I've been at Expedia for about 3 years now as a director of data engineering. So just kind of like the mission, I've done, as I said, I've worked for IBM for a while. I've worked for Sky, but in terms of like moving to Expedia, it's a truly data-driven company, more so than I think the others I have seen from my kind of data side. So we've got kind of like a whole bunch of analysts, more analysts than you can actually ever imagine. There's analysts everywhere on my floor. Who are doing analytics, looking for innovation, and we need to make sure we've got scalable pipelines for that sort of thing. So when I first joined in 2016, this is what the kind of technology stack looked like, and a lot of people will probably recognise this. 2016, our data center was on-prem. We were using Hadoop, HDFS. The analysts were using Q. We actually had what we called a speed layer, which we were using Teradata for. And using SAS for an analytics tool. And if we look now, this is since I've just been here for these few short years. Everything is on AWS, obviously still using Hadoop, but the data lake is in S3. We're using Qbol for our data exploration. That's one tool. We could be using many others as well, but that's what we've chosen for the time being. Redshift is our speed layer. But again, that could trying to be kind of like cloud agnostic. And in theory, you could use something else. And RStudio for the analytics tool. We use everyday open source, so yes, Hive, Vue, Spark, Jenkins, Cascading. I wasn't going to go too much into some of these, but in general, that's kind of what we use. But I wanted to look at it from a data pipeline point of view. So if we look at a kind of typical data pipeline that obviously you'll all recognize, we ingest data, we transform it, we use it in some way, visualize it, allow it to be available for analysts. And then often we replicate it or back up or copy it or whatever. We also need orchestration and monitoring. That's going back to my production support days, making sure that works. And more increasingly, we want data quality. So data quality has always been an issue, but we're finding more and more, as more and more data science or other models are being trained on data, we have to make sure that our data is really accurate. We can't really have situations where you can't use June 2016, guys, because we had a bit of a problem. That doesn't really wash anymore. And then accessibility. How are people accessing this data, particularly in the cloud? So let's look at the ingest. So previously, we'd have lots of teams landing data all over the place using different formats. Naming conventions were unusual. We'd have jobs breaking down because of schemas. We wouldn't, users wouldn't know when a new partition is available. So we wanted to look at what can we do about this? We came up with our engineers. My engineers came up with the data highway. It's a cool name, but essentially it's a Kafka stream that's got a kind of managed Kafka stream, so that the users don't have to know too much about it. Essentially, we have consumers and producers. The producers really just register their schema, and they can just kind of land that data, and it will basically either through a stream process, but also on a batch process, land it into S3 with a Hive table on top of it. So that's been extremely useful. That's probably a rubbish slide for this audience, just because you can't really see it. But that's the kind of like the architecture behind it. there's a simplified version there. It's really, really straightforward. But it basically means that we can land data from the online side as well as the offline side that analysts can pick up from their Hive tables. And it's been so much better. We're using Avro format so that we can actually have a kind of schema evolution, and it's just made things a lot easier. We can actually notify when those partitions have actually been generated, so we can trigger downstream jobs or just let other people know. Looking at transformation, so one of the problems we've got is that a lot of our legacy jobs are using MapReduce, cascading. I don't know if you guys have used any of that before, but it works fine. But when you want to move to the cloud, it's very, very difficult to use that. And we in general want to move to using Spark and obviously Scala as our language. I've got a really good example. This is one we put in about kind of 8 months ago. So we have a speed metrics warehouse. Essentially, it's the website speed, and it's important for our A/B testing team because they need to know whether their testing is affected by how long it took the pages to load. But the actual application used to run for 16 hours on a 100 node cluster, which was pretty expensive, and we weren't really sure if it was going to actually complete each night. And it was written in Bash, Python. There's a bit of a hodgepodge of all sorts of things, and it certainly wouldn't scale properly. We actually added more nodes, and it still didn't make it go faster. So we wanted to kind of like move away from that, rewrite it in Spark so we could use the caching model there, and actually look at the architecture. So it wasn't just about rewriting it. It was actually about looking at the architecture and finding where we could make changes there. So just an example, there's the kind of like the rough version 1. If you look, it's again just a kind of general data pipeline but when we looked at the architecture and analyzed it, we found that like the ranking table, for example, was just being read 8 times, which is crazy, which is why it was taking so long. One of the reasons. So when we rewrote it, we got rid of the explode phase, and we actually used caching. So the rank table was completely cached, so it only had to be, it could be read in memory the whole time. The results: reduced complexity, less code, was streamlined, smaller cluster, no more shell scripting, which is really nice, particularly from the data engineers who are desperately trying to move away from that sort of thing. And looking at the costs, I won't put the figures in here, but let's just say that we reduced our costs by 85% on our EC2 costs. Got it down to 3 hours, finishing the same day, and on a 25-node cluster. And that's purely from rewriting and re-architecting. So there is absolute results to be made from doing this. Replication. So here's how our on-premise situation was. As I mentioned, we were running all of our ETL jobs, and users were actually pulling data from there. And they had a terrible time. They were always complaining about it being slow. They were always complaining about not being able to get their queries on time. And they were only actually allocated about 10% of the CPU because the other 90% was for running the ETL jobs. So the first thing we had to do was get those users off. So how are we going to do that? We need to basically create a replication into AWS so that we can still keep the jobs where they are, but they won't get interfered with by analysts running queries. And we want to get to a situation where we can run ETL jobs in the cloud, turn off our on-prem, and also replicate into a different region if we want to, at least have the ability to do that for a backup. So again, we created, what we needed was essentially something that would not only just copy the data from HDFS into S3, but it would also move the metadata as well, which is vitally important. We also needed it to be, data metadata coordinated, and we needed to be consistent. So not just, while it's being, we can't turn it off and say to analysts, don't use this data for the next half an hour because it's updating. We can't really have that situation. So we created something called Circus Train, which essentially does exactly that. It allows you to move data from Hadoop into S3, but it also allows you to move data around within regions and accounts within Amazon as well. You can either do a partition, an entire table, or you can do a subset via a SQL query. And it's now open source, so anybody can go there and look at that. Just a quick idea of how it works: reads the metadata first, reads the data, and then uses runs on an EMR cluster within AWS. But then, more importantly, it creates these snapshots. So again, the snapshot will not update or will not allow the user to update until that snapshot has been taken and until the meta store has been updated. So that user can never be out of sync with the data, and they will never get partial data. And also allows us to send an SNS email for that. This is an example of what it looks like running within AWS. I'll talk about the Azkaban and stuff later. So this has been massively successful. We've spent the last 2 years moving users onto a new platform, which was AWS. From their point of view, they didn't really care because they could get their data, but they didn't even know that they were connecting to somewhere else because we were replicating that data. The only slight problem was that there's a little bit of a data lag, obviously, because you've run something in production on Hadoop, on-prem, and then you've got to copy that across. So there is a short delay, but most of our jobs kind of run overnight, so it was just part of that process. Now, getting to data quality. I set up a data reliability engineering team about 6 to 8 months ago, and the sole purpose of that team is to look at data quality. So we looked at something called Apache Griffin, which is, I don't know if you guys have looked at this, but it's a really interesting open source tool that was created by eBay's engineers, I believe. It's a proper platform. You can run Spark SQL on it, so you can actually set up your jobs, and it's got a lot of kind of offerings on there already. It's got this is the architecture. As I said, it's got those kind of like 6 built-in processes. The UI, I would say, is not that great, but there's a good opportunity there for anybody who wants to contribute. They're desperately looking for people to contribute both to the UI front end and the back end. There's a tool that we implemented a while ago. This was open sourced about a year ago. Essentially, Quibble, we use this, which is a data validator. It's relatively straightforward. It runs up a single machine. All it does is basically runs a SQL query on the target and a SQL query on the source. It does a kind of minus between the two. And then it's set up with a simple config YAML file. And here's an example of how it actually works. So this is a SOX compliant data flow of one of our accounting system for our loyalty warehouse. It basically moves data from a SQL. We have to pull data from a SQL server warehouse and pull it into Teradata. And we use Quibble at each point, and allows us, from an audit point of view, to be able to report that to the audit team that every step of the way we haven't lost any data, basically. That's just a look of kind of how the email looks once it's sent out. Now, orchestration and monitoring. We spent quite a while looking at various different open source products for this. The first one we started working with was Azkaban. I don't know if anybody has kind of played around with that. We found it was really useful for actually setting up our Circus train jobs between the on-premise and AWS, mainly because, and I'll show more about why that was, but mainly because it was really useful for the ops teams that they picked it up really quickly. We also looked at Airflow. Airflow, those of you who've used it, it's Python-based. The programmers love it. The data engineers love it because they can write their own code in there. But it's also really scalable. There's some other interesting facts on there about Airflow. But comparing the two, so this is basically what we did. Went through all of the pros and cons of everything. Airflow's got like a large community. It's scalable. The UI is okay. I mean, most programmers like the UI, but it's got lots of hooks, EMR, SFTP, loads of really useful stuff that's already been built. And obviously there's contributions being put into that all of the time. Azkaban also doesn't have as big a community, but it's really simple to install, and the ops team love it. So you can give that to ops team, and they know how to restart jobs. It's really kind of nice, pleasant UI. The bad stuff, Airflow is not that mature. It's getting better. The UI is not friendly from a kind of like giving it to an ops team, but you have a lot of more ability to kind of restart jobs and to have auto restarts, which is great. And it doesn't really work with dashboards. I don't know if anyone has used Azkaban. Launching an EMR from there is quite painful. In the EMR cluster, you've got to write a lot of code to get it to do it properly, and it's not that feature rich. Dashboarding. I'm sure lots of people look at Grafana. We've been using Grafana for pretty much everything, building our stuff on all of the stuff that's good for our own individual batch jobs. We use Grafana for because it's useful for the engineers to be able to see it, but it's not very friendly for analysts to be able to see it. So we've started using Superset for that, which is an open source kind of visualization product, which we have started using for the analyst community for putting on like TV screens and stuff like that, and they found that really useful. So those who haven't seen Grafana, that's kind of, as you can see, it's not that great for an analyst. It's fantastic for being able to check your jobs each morning. That's Superset. That's just, you know, an example of what it can look like. It's no Tableau or anything like that, but it's free, it's open source, and it actually looks fairly decent, and it's easy to set up. Accessibility. So one of the problems we have had as a company, as I mentioned, is that we have hotels.com, we have Expedia, we have data science. So we've got lots of different accounts within AWS, and they're all siloed. How do you join that data together, which is what I alluded to earlier? So we looked at lots of ways of doing this, couldn't find anything. So one of our platform engineering teams came up with a way of kind of pulling that together. They called it Waggle Dance. Came up with a nice name for it as well. It's useful. Essentially, it acts like a kind of metastore proxy to be able to kind of basically for an analyst to be able to query across accounts without realizing they're querying across accounts, which is exactly what you want. You want your users to be able to not kind of see anything really. This is just a brief look at how it works. It basically creates a kind of like, as I said, a federated metastore across the two accounts, and allows a user to be able to pull data from one account from the other. And it also acts really good because Hive security is not that great. You can actually set up your own security on here as well. So to be able to just allow users to read certain data that you probably couldn't do if you gave them access to the full account. And just an example. So here's you've got two accounts. You've got your main account, your data science account with two databases in there, ETL and ML. And you basically got two tables in there that you want to join across with your ID. So you're trying to pull the image for that particular hotel. If you set your Hive parameter there, your Waggle Dance parameter on there, and then do the same thing, essentially you'll be able to see both the databases, and then even better, the query, the user can use the Waggle Dance to actually pull that through and give the right example for the query. So it's highly useful. And then this is just about putting the whole thing together. We decided that if we've got Circus Train and we've got Waggle Dance, why can't we just put all of that together in one kind of open source application, which allows you to basically install both Waggle Dance and Circus Train, and then this is how we've set it across our accounts, across our other regions as well. So it's just an example that other people can use it, but it's there if you want to use it. So that's how we've actually set that up, and it's been extremely successful. So we've now been able to pull all of our brands together. So Expedia analysts are able to look at hotels.com data, and Verbo analysts are able to look at everything and join that all together. And it's kind of opened up new opportunities and new kind of like innovation strands for the analysts. And just finally, that's just an example of kind of like how our ETLs look now. This is, we're using Airflow, we're using Waggle Dance, we're using Circus Trade to pull in data from where we need to. So if there are other accounts, we can pull that data in. We can use Waggle Dance to actually query the data. We're using Quibble or an equivalent like Griffin. We could substitute that for our data quality. Using Redshift when we want to push that out for a speed layer to users. But as I said, that could be any other warehouse you wanted to. And then we're using Superset to help visualize that. We're just a quick note on what we're doing next. There's loads of other things we want to do. It'd be nice to look at, we've got a Cube solution at the moment we use, which is on SQL Server. We've looked at Hadoop Cube solutions or Big Data Cube solutions in the past. That haven't really worked. but there's been a lot of new work done on those. As I said, these open source tools are being improved all of the time. So that, we're just constantly looking for new ways of doing things. So that's it. A kind of whirlwind tour of how our kind of pipelines look at